Hey everyone, and welcome back to the channel. I am Kush Srivastava, and today we are embarking into exciting journey into the future of artificial intelligence, a future AI where system doesn't just answer the question but actively do the things to achieve the goals. We are talking about the agentic AI. If you have not been fascinated by rapid advancement in AI, especially with large language models, then you absolutely need to understand what agentic AI is. It's truly the next frontier of the artificial intelligence. In this video, we'll break down what AI agents are. We'll explore some powerful frameworks of AI agents like OpenAI SDK. We'll explore more about the CrewAI, and then we'll explore more about the MCP protocols also. You will have a you will have a clear picture of how these autonomous systems are poised to revolutionize everything in the software development to even, and along with that also even global economy also it will be impacting. So let's start with the fundamental question: what exactly defines the AI agent? At its core, an AI agent is a program where the output of large language model or LLM directly controls the entire workflow. This is just about the LLM generating text. It's about LLM acting as the brain, so that decides what steps we need to do, take what tools need to use, and how to achieve a given objective. Think of it, LLM is having hands and feet, not just mouth, not just voice basically. So this capability basically opens up individual array of possibility. So imagine we are having a code generation team where AI agents can write the code, collaboratively review the code. By collaborating with other agents, it can refine the code. It can significantly increase the software development cycle, and it can revolutionize the healthcare diagnosis by assisting in healthcare. So it can go through large amount of test reports, patient record, and research to suggest potential diagnosis, and it can significantly impact into this area. And then we have scientific literature review. So for researcher, agent could perform scientific literature review, summarizing the key findings, identifying gaps, and even designing and running experiment autonomously. They could plan the experimental setup, so this can significantly impact this area. Then we have design and run experiment. So the agents can design and run the experiments also. So with this, there is a large debate going on that in future, in enterprise work tasks, can this agent replace the humans also? Indeed, they are replacing also, but not at much extent right now. But in future, there is a possibility that these agents can significantly impact and replace the human works. So with this, there is a very cryptic uh, debate going on. Uh, can these agents, like, will there be any regulation for these agents also? Well, that depends on the future. We'll explore more about AI agents. So to further understand agentic AI, it's helpful to differentiate between two core concepts by Anthropic. So Anthropic is the organization who developed the MCP basically. So we have one, Anthropic categorizes these agents into basically two categories. One is a workflow, one is agent. So think of workflow like a code path. So this is where the AI follows a set of explicit pre-programmed instruction, much like a crafted recipe. Every step is known in advance, and the system executes them in sequential or predetermined manner. It's powerful for a repeatable task, but lacks the it lacks the flexibility for if any unforeseen circumstances come. Then we have agents. Agents are, it is paradigm like LLM decides their own tool dynamically. So let's suppose we are giving any prompt to agent, and this means not agent, yeah, agent. This means AI is not just following a script; it's actively accessing the situation, deciding which tool we need to use and how to use them in real life to achieve its goal. This dynamic decision making is what sets agentic AI apart and unlocks its incredible potential. The dynamic anatomy is powered by the concept of LLM autonomy. Essentially, tools are what give LLMs true power to act autonomously. So initially, LLM has the information what we used to train the LLM about, but now we can integrate other tools to LLM so that it can have much more information. So we can have web search tool to get information about the current events. We have perplexity to get about the latest information. Then we can have file search tool to so that LLM can search the file. And also we have lot of tool like it can have Wikipedia tool to get access about Wikipedia content. Then it can have ServiceNow tool to get access about ServiceNow incident, SRMs, and these things. So for instance, a agent might use a web search tool so that it can gather the latest market data and these things. So one common risk what we associate with is privacy and security. Can OpenAI or any other AI developer reach into your computer? This highlights the critical need for robust security measures, clear permission, and ethical guidelines as this system outcome more integrated into our digital lives. So further, we have some agentic frameworks. We'll more explore more about. So first framework is no framework. So yeah, it sounds weird, but no framework is like we can access the LLM just by having the API keys. So just like how we can integrate our code to let's suppose OpenAI ChatGPT by their API keys, and we can do it through their chat completion APIs. So no framework is also a very popular framework. Then we have OpenAI SDK. So OpenAI Agent SDK is recently launched last year only. I think 3 4 months back only it is launched, and it has significantly revolutionized complete AI area. So by this, we can integrate multiple AI models into our system, and then we have MCP. So MCP is Model Context Protocol. That means USB-C of any AI application. So how LLM should integrate other tools like web search tool, Perplexity, web search, then we have Wikipedia, then we have ServiceNow, then we have Jira boot. How this integrate? So we have defined one a protocol for that, so that if we change anything in our external system, we don't have to change everything in backend every time. That's how this MCP helps. I've created a separate video of MCP. You can go through that video and explore more about. Then we have CrewAI. So basically CrewAI is like it is a agentic framework only. So it is basically used in multi-agent orchestration. So let's suppose we have a crew of multiple AIs. When one AI agent can hand off the task to other AI agent, and other AI agent who is just more proficient to do that work can do that task, and it can hand off to simultaneously other agent, or parallelly it can run multiple agents to boost the performance also. We'll explore more about the OpenAI agent SDK. So while to create this AI like agent with the OpenAI SDK, basically we have three steps. First step is create agent. Second step is utilize trace to record, because it is a critical feature for developer. It is ability to trace the agent's execution. This allows you to monitor its decision making process. Then we have invoke function. Invoke is the by running a runner.run, it will invoke the agents. So by this, agents can execution of agent will start. Then we have web search tool. This is crucial for up to date information about the latest data. Then we have file search tool and computer tool. What I've already defined, computer tool is basically it provides a gateway for agents to interact with the underlying computer system. executing commands in our own computer directly. Like you must have, if you are using cursor id, then you will know about computer uh, agents more. uh, Now we'll have a quick demo about this OpenAI agent SDK, how we can create the agents. And uh, let me open the ID. Let's start the demo of this OpenAI agent SDK. So in this simple example, basically we are trying to just make the connection between OpenAI models from our local. So we are passing a OpenAI API key into .env folder. We are fetching it, and we are making a variable client. So then we are using this chat completion model. We are passing the model like 4.1 mini. We are using very basic model just to save the cost. You can use the advanced model like GPT-4. Then we have turbo models which are more advanced model. We are passing the message. So this message is like tell a joke about autonomous AI agents. Let's run this to get the response. Yeah, we have a response. So it generated. Why did the autonomous AI agent bring a map to the party? Because even it didn't want to get lost in the cloud. Yeah, sounds funny. So that's how we establish a connection between OpenAI agent from our local. Let's explore some advanced solution for this. So in this example, basically we are trying to make a multi-agent system where one agent will orchestrate the work to other agent. So our plan is to create a four agent. One is the search agent, one is the planner agent, one is the report agent, and a report writer agent. Then we have a push agent. So basically, we'll give one prompt to this search agent. It will search about that topic. So we have given instructions here like you are a assistant given a search term. You need to search for web and produce a concise summary for that result. The summary must be 2 3 paragraph and less than 3 words. And we are using parallel searches. So how many searches we are doing? So we are doing two searches here. You can increase number of searches more to get a good result. Then we have a planner agent. So yeah, in search agent, basically we are passing the name, instructions, what prompt we are passing. We have a model, then we have a tool. So tool is web search. So I already explained like how we have to integrate tools, like how this OpenAI agent SDK is having the inbuilt web search tool in the SDK model only. So this basically search agent will search about it. Then we it will orchestrate its content to planner agent. So in planner agent we are giving instruction like you are a helpful research assistant given a query, come up with the web searches to perform the best answer to the query. You must return your response in valid JSON format with a search and containing objects with a query and region fields. Then we have a writer agent. So writer agent basically it will write a research report about these findings, what plan a planner agent has made about these search, multiple search, and it will pass to a writer agent. Writer agent will write a report summary about these, and then push notification agent will be triggered, where user will get notification that your search is completed. So we have used push over for this push notification. You can also go to push over website or application and get your username and token to get this. So let's let's see from the main. So this is a main. So we are starting our research. We are passing the query. So here I'm passing the query. What are the most popular and successful AI agent framework in May 2025? It will pass to plan searches. So it will do like two total two web search to get more information about what is the most powerful and successful AI agent. After that, it will perform the search and it will pass to this write report method. In write report method, will pass this query and will pass the search result. It will write a report. So here I'm passing. I've written a method like write a report based on the search result. So it is also using a GPT 4.1 mini model and agent by this research agent, research writer agent. It will basically write this complete research report and will just return this report. After that, it will go to this send push method where a user will get notification in their system or mobile phone that your research is completed, your research report is completed. Let's try to run this once so that you'll have a clear idea. I'll push this code into Git and share in the description so that you can get a better idea about this by building in your own local. Let's run this Python file. So our plan start. So it is performing four searches. It is searching on the web. Now it is writing up the report. So one agent is orchestrating, one agent is doing handoff to other agent to further complete the task. Then we have a push agent. It pushed the notification. So see, I got a notification to my mobile phone that it is completed. So here is the push notification like your research is complete, and here is the research report. So see, this is a complete research report in very structured format what leading AI agents are. So it has TensorFlow, OpenAI, then Microsoft Bonsai, then we have Hugging Face Transformer, and then it has Anthropic's Cloud Agents. Then we have DeepMind's Gato 2. So all the leading AI agents it has into this report, and this is a complete report. I hope you like this agentic application demo. Now let's learn more about the CrewAI. Let's start about the CrewAI. This involves the sequential designing prompts to handle the task by multiple crews, what we define into as agents into this. So this is a robust framework, but it is specifically designed for building and orchestrating multi-agent system. We have a prompt chaining here. So this involves like sequential designing prompts to give guide the agents through a series of logical steps so that we have can ensure the coherent flow of the information and actions with these crews. So in this we have a LLM, then we have a role. So role like we can define one manager who can oversee the other crews. Then we use the models like which model we need to use like GPT-4 or anything. Then we have a goal, what goal we want to achieve through this crew. Then we have a task for each crew, like there will be one crew which is, in this example, it is looking about other task of other crews. So this is hierarchical pattern. Hierarchical means one crew is taking, one manager crew is there which is overseeing the tasks of other crew. Then we have sequential pattern. In sequential pattern, basically there are a series of crews that will perform the task, and it will hand off or orchestrate the task to other crews. Then we have a routing. So routing means like different agent or subcrew can work on different parts of problem concurrently. So then parallelization means multiple crews are there. They can work into the parallel so that our task can be divided into multiple subtasks, and we can complete the task into less time and more efficiency also. Sequential hierarchical we have understood. Let's start like how this CrewAI can be developed. So there are 5 steps like we saw into Agent SDK. There were 3 steps. So for CrewAI there are 5 steps. So first step is like this crew we need to, let's suppose we are creating with CLI. So first we have to define this agent a task in the YML file. So in YML file we'll create one agent task where we'll define all the agents what we are do, like what are the crews we are using. Then in one file we will one config file will define the task of this crew, like which crew will perform which task. And in crew.py file basically, so all the core logic of this crew will be implemented into this file, and this will be a Python file. Then we have an input file where will, it can be GUI, it can be terminal, where we are giving prompt to these queues. Then we have to run this report, run the project, like run these queues systems. Let's start the demo about this QAI once, so that you'll be having a better understanding about this. Let's understand the QAI with the demo and example here. So here, as I have defined, like in QAI, basically we have to first define the configs. So in configs, we have to define all the crews, and then we have to define all the tasks that this crew has to perform. So what demo we are performing, we are basically creating an engineering team. When there will be one engineering lead, there will be one backend engineer, there will be one front-end engineer, and one test engineer. So engineering lead will basically direct the work to other engineers, and we have given a task, a role here. We have given a goal here. What is the goal of engineering agent in lead? So the goal is take the high level requirement described here and prepare a detailed design for the backend engineer. Everything should be in one Python model. So all the instructions for this engineering lead we have given here. We have given a backstory, and we are using GPT-4 model here. You can use advanced model for a better result. Then we have a backend engineer who will basically code all the things, and it will create a backend module of this application. So we'll create a trading application where this, for this trading application, this backend will be created by this agent backend engineer, this crew a backend engineer. So we have defined everything. We have defined the requirements in requirement folder files. We have defined a module name. So uh, we'll pass this module name, and it will create all the backend module for this. Then we have front-end engineer which will create a UI layer for this application. Then we have a test engineer who will basically perform the unit test for these front-end and backend modules. Let's understand it better, what task it needs to perform. So these are the tasks like design task that engineering lead will perform. Then we have a code task. Then we have a front end task, what front end engineer will perform. Then we have a test task, what test engineer will perform. These are the configs files which we have to define first. Then we have a crew.py file. In this crew.py file, we'll define this crew. So first is engineering team, what we are trying to create. In this engineering crew base, we are creating three agents. One is engineering lead, one is a backend engineer, one is front end engineer, one is test engineer. We have given these engineer, we have given execution time and a retry limit. All these configurations we have given here, and these are the tasks what they need to perform. So this design task, engineering lead has to perform this code task, backend engineer has to perform front test task, UI engineer, and code task, this test task has to performed by test engineer. Then we have a crew here. So it creates the research crew. Basically we'll kick off our crew base from this function. So let's go to the main function. In main function, basically we have defined our overall goal, what we want to achieve. So we want to create a simple account management system for trading simulation platform. System should allow user to create a account, deposit funds, and withdraw funds. These function it should have. Users should be able to withdraw also. Allow users to record their, they should have their portfolio also, total value of portfolio. And these are the functionalities what we have given in the requirement, what we want to achieve. We have passed the module name accounts.py. So this module name will be passed to backend engineer, and it will create accounts, all the backend code into this file. Then this is a class name, account class, in which all these modules will be there. Requirements folder, module class, and class name. Here we are kickoffing this crew file. So it will basically go to this, and it will call these agents. It will call first to engineering lead, and engineering lead will basically create a design. It will simultaneously orchestrate to other agents. So I have already completed this code flow. I'll push this into Git. You can check out the code and do this on your behalf to understand it better. Let's see what output it has created. So this agent code is also created by uh, agent only. So I'm using cursor ID. So using this cursor agent only, I have created this complete code flow for this agent also. And this agent has created a different model. So here in src you'll see a output folder here. So here is the output folder what it has created, this account.py. This is complete backend of this application what it has created. It has these methods: get share price. Then in account class we have deposit funds, withdraw fund, buy share, sell share, calculate portfolio value, calculate loss. These all the methods which is necessary for this it has created. Then we have, it is our design folder what design engineering lead has created. It has given all the overview and all the high level design for this application what needs to be done by backend and UI and test engineer. Then we have a UI layer for this application. So we have actually used a Python library, Gradio library, to create a simple UI layer for this, and all these functions are integrated here. Let's try to run and look at it once. I've already started it in local. Let's go to this and check it. Let's see the demo of this application what is created by our CrewAI agent. So this is our main page of this application, trading simulation platform. We'll try to create one user ID. Let's suppose 12345. This user ID is created and our initial deposit is $1,000. We are creating account. So this user ID is created with a portfolio value of $1,000, and we can deposit more funds into it, and we can withdraw the amount. Let's try to withdraw the $200. So our portfolio value is 800 now. Let's again deposit the $300 into it. So our portfolio is $1,100 now. Let's try to do the trading. Let me buy a share for Apple. So Apple, let's suppose we are buying the two quantity of share. So we have successfully bought two shares of Apple, which is $150 each. So it should reduce $300. So our now portfolio value is 800 1100 only, because 300 is into the market now. So this is our report where we can see our portfolio value, we can see the profit loss, and we can see the current holding, and all the transaction history we can see here. We can sell this share also. So let's suppose we want to share one Apple share, so we can sell also, and our portfolio will be updated in by this. So now in our holding only one share of this. So this is simple application which is created by this CrewAI, but all this UI, backend, frontend, everything is completed by this CrewAI agent only. I hope you like this CrewAI agent SDK demo, and I'll push this code to Git and put this Git link into description so that you can explore this and do the coding on your behalf to understand it better. Thank you so much.